Hello, Amin here from Shirtomoto. Today we're going to do a quick video talking about how to effectively gather CPU metrics from a running Linux system. This is very important for two reasons. The first one is that you need to be able to gather this information during a production outage when troubleshooting a system. Now, a lot of people will then say, well, Amin, we have our dashboards and our time series. Yes, that's absolutely true, but sometimes those dashboards are going to lie to you. And what I mean by lying to you is that you can't capture all of the CPU metrics at an infinite level of resolution. There is something called rollup, where metrics are aggregated and bucketed into slivers of time. And the further back you go in your time series, the larger those buckets are. So intermittent spikes in CPU utilization will not be observable. So that's what I mean by your time series and your dashboards will lie to you. Secondly, this is actually really, really important when interviewing. There is a type of interview known as a systems interview, which is common for larger companies like Meta or Google and places like that, FANG companies, where they're trying to assess your knowledge of the operating system, particularly Linux OS, being able to gather metrics from it, and then demonstrating your ability to troubleshoot. So if you want to be successful at a systems interview, it's good that you understand and know this skill. So when I interview candidates and I ask them, okay, as part of whatever question or scenario I give them, one of the things I am trying to assess and probe is, hey, can you interpret CPU utilization on the running system? And this is usually the moment where the candidate's like, yeah, sure, we can just run top. And that's great, because top does display that information. But then, of course, I am now going to ask you, okay, great, you understand that top exists. Can you interpret the metrics for me? And this is usually when candidates tend to fall down. Because yes, you have these metrics here on the top, and it's telling you what programs are using the most resources, but it's not actually telling you how the CPU is being utilized itself. So let's talk about that. The third line of top has these metrics, these 8 metrics along here. And these metrics is basically the percentage of the CPU time spent doing those specific activities. Now, if you press 1 in top, you will see those same percentages across each core, but usually it's represented in one line like this. So that is the aggregated metrics percentage of time across all of the cores. Now, you can gather these metrics from other tools. You can also see them from tools like vmstat on the right there. You can also see it in dstat, which is one of my favorites. You can see that there. So you will see these metrics in most tools. So if you understand what's going on in top, you're going to understand what's going on anywhere. So let's get right to it. The first metric is US. That means user space. This is the time spent by applications or server processes crunching numbers and actually doing what it is that you purpose the system to do. So right now I'm running OBS. That is how this video is being recorded. It is doing a whole bunch of data processing in order to record my voice and to record the screen. And so that utilization metric is corresponding mostly to OBS. Secondly, we have SY. That is system, meaning the time spent by the OS, the kernel, doing operations. Now, in the context of servers, like if you're troubleshooting or diagnosing an issue on a production system, I tend to see SY trend towards the amount of CPU time spent reading and writing, like doing I/O to a network device, especially for systems that are load balancers. I tend to see elevated metrics in SY for that sort of thing, but depending on your workload, it can mean completely different things. But that tends to be one of the primary contributors, at least based on my experience running production systems. The third item is NI. That's nice, as in nice processes. So it's very similar to US because it is user space, but this is the percentage of time spent by the CPU running user space processes where the priority has been changed. Nice processes can have more priority or less priority in the system run queue. So it's good just to know. You tend to add these two together and then you understand, okay, this is the time spent by the CPU running user space across the whole host. Next is ID. ID is actually really, really important and a quick place to look when running a tool like this. This is idle. This is the amount of time spent by the CPU not doing anything. So if you see this metric going to 0 or approaching 0, that means that the CPU is totally utilized. A really interesting thing to note is if I broke it out into each core by core, and you see that idle is 0 on one of them, that means you probably have a single threaded process taking up all of the CPU cycles on a single core, which is a good thing to check because sometimes that is the case. And if you're just looking at it like this, you won't be able to easily catch it. Next is WA. WA is I/O wait. This is the time spent by the host reading and writing to block devices. So NVMe, SSD, spinning Rust hard drives. So this is really, really important to check, especially on database servers, because if you have high levels of I/O wait, that might indicate that you just have way too much read and write operations going on in the host. Maybe your storage device is too slow and you're simply constrained. But this is a very common place where CPU time can easily be consumed on a production system. So I would definitely be checking for that. That's a telltale sign of something relating to storage. And then we have the final three, which you don't see super often, but we'll go over them briefly. You have time spent in hardware interrupts and software interrupts. So that's basically the time spent by the CPU handling those types of events on the system. And then finally, you have, this is not super common, especially for laptops and bare metal systems. This is time spent in CPU steal. So steal is relevant when you're running a virtual machine. And that is the time spent by the CPU where those cycles are being stolen from the hypervisor to allocate to other guests on the machine. So I am recording this video on a laptop, so ST should be 0 at all times, but those are all of the metrics. So that's it. Hopefully this bit of information has been very helpful to you, being able to interpret CPU metrics on a running host. Again, it's going to help you when troubleshooting production incidents. It's going to help you when interviewing. So this is Amin. Thanks so much. Signing off.